Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about direct storage in Windows. So let's dive right into it. Now, what exactly is the problem that we need direct storage to solve it? Well, game worlds are becoming complex and huge, and I used to work as a game artist, so I can tell you, like when we started as a child and playing video games, for example, IGI, basically the amount of textures and amount of assets that we were spending on main game became something. Now when I was working as a game artist, I was spending that kind of asset and basically memory on background. So fundamentally the amount of horsepower, the amount of calculations needs to be done in game world is grown exponentially, and at this point in time game sizes has literally crossed 100 GB mark, meaning almost all AAA title that's supposed to look like a AAA, not an artistic kind of game, generally they will cross 100 GB reliably, and again with add DLC and all that 200 is like minimum. So that creates an issue. At this point in time, the imagination and the tools are exceeding the capacity of the hardware, meaning game designs are being limited by it, meaning what can you design, what can you draw, what you can represent in the screen is now limited. And generally basically game companies try to work around it, meaning the slow loading. I'm not talking about the graphic fidelity, I'm talking about basically asset loading. That's the main thing, because the game world is so huge. You can reuse old assets, that's what we do all the time, but there is a limitation to that. And I can guarantee you, any game you see, especially from high up, you start to fall, you will see, hey, there's one texture is just tiling hundreds of times. You notice that. Why? Because we do not have the luxury of having multiple textures, simply because the memory loading is the bottleneck. It's not that we can't put other textures, the memory is just not big, the pipeline is not big enough. So how do game developers right now, as in people who are working right now, solve it? Well, they introduce scenes like this became a very infamous scene from Deus Ex Mankind Divided, because like again it has like 3 or 4 scenes like this where it's like, you know, he's just walking down the track, and it's like it's hilarious because it's again the game was poorly optimized, but this could take around 3 to 5 minutes. You can just walking this dude, like, you know, just walking 3 to 5 minutes is like the most common comment around this sort of video is like, I wasted hours of my life watching this. It happens. Like this is basically some other game that you may have known of, Assassin's Creed, and this is Destiny. So you get that point. Like people generally try to do something creative while they are loading the stage in the background, and this sort of things are now reaching a point where people are like, dude, I see what you're doing, can you do it any faster? So these sort of hacks are no longer working, and that's why like companies, especially in Halo Infinite, you will notice it has a bit too much of elevators. Why the heck it has elevator? It's trying to do its best to load things in the background. So that's the problem. Like literally game creation is being limited by our faulty design. Now, what exactly is this quote-unquote limit? Now, limit is not in terms of horsepower, because think of it this way, like we started with hard drives which barely could give you like 50-60 Mbps. Then we went to SATA, then we went to SATA 1, SATA 2, SATA 3, and now we are at a point where even a basic, magnetic platter disk can easily give you 250 Mbps sustained, and SSDs can easily reach 400 to 500, and NVMe SSDs can go up to gigabytes per second. So that's not the issue. Then what else is the issue? Issue is the pipeline. The data pipeline is outdated, meaning it's by default designed in a basically early days, as in 1970s and 1990s, CPU as a core. It assumes CPU is the mother and father of everything basically, while it is true, it does create an issue. Basically game itself is being run on the CPU. That means CPU is already at 100%. So how the heck CPU is gonna do IO operations? IO operations simply means input and output commands. Now that request, basically graphics card is like, hey, I want this. So graphics card will send that information to CPU. CPU is like, okay, I got it. It's gonna call to NVMe drives, even in the modern system, and then NVMe is gonna feed that data to RAM. RAM data will be compressed. Basically all games are compressed. Basically when I used to work as a game artist, I will submit files in, let's say, Targa format, but you will never see Targas. There are generally custom archives that they use to compress, lossless compression, but those lossless compression is stored in NVMe. So but again, it cannot be run directly, so generally it goes to system RAM, then it goes to CPU. CPU decompresses it, and then it sends to RAM. Then RAM feeds that data to GPU RAM, basically VRAM. So you get that point. Like this is a bit too much TikTok that's going on here. However, modern CPUs and modern GPUs and SSDs specifically have grown exponentially in their power, meaning they started with assuming 1 horsepower, now they have 10,000 horsepower, meaning right now supercomputers, instead of using boatload of CPUs, they are using boatload of GPUs. SSDs went from barely able to do like 500 to 600 Mbps to gigabytes. At this point in time, you can buy, if you have the money, to buy around 6 gigabyte per second kind of SSDs, especially in read operations. So we have more than enough horsepower in SSDs PC and GPU to bypass this jumping around CPU link, and that's the whole thing. Right now what's happening is like GPU needs something, CPU must execute, basically must extract the file, decompress the file, then feed that file. It's too basically it has too much overhead and too much lag fundamentally, because like steps, even no matter how fast each step is, but if you have 10 steps super fast step versus 2 super fast step, of course 2 super fast step would be much better. So that's the whole point with direct storage system. Direct storage, basically you have NVMe directly gets the command. Now you're like, how the heck NVMe can receive a command? Basically it receives command through PCI language. PCI Express is a protocol. It works between two things independent of CPU. So it gets the data. It's like, hey, GPU is like, VRAM, can you please give me this data? That goes to system RAM generally. Again, that also can be bypassed if you have a different kind of design. Be mindful, it's an issue, especially if you're talking about consoles. The RAM is distributed, so it will go to system RAM, then it will go to GPU RAM, and then GPU itself will do the decompression directly. It will be far more efficient, far more effective, because GPUs are designed to do one task. So that decompression is like, I got this, I can do it like, very efficiently. That's the limit right now. It's like this hip hop that we are doing is fundamentally taxing the CPU, because CPU is already maxed out. You're trying to run the goddamn game engine itself, then trying to run the whole game or all the physics simulation, and on top of that you are also giving it, hey, these IO commands, they are time sensitive, because if you do not do it on proper timing, you will have a scenario where it's like you walk to a door and you open the door, there is nothing on the other side of the door. It's just a blank screen because it did not load properly. So IO requests are what we call time critical, meaning it has to be crunched properly in proper time. So you get the point. Like, this is the limitation. That's why people have always noticed it, like no matter how fast you put your SSDs, you will go from 500 or 200 Mbps per second mechanical drive to 600 solid state. There is not that much of a difference. Same happened where you went from 600 to 6000 Mbps. Still not that much difference, simply because of that hippity hop thing. This fundamentally is limiting things, because again, people who design the game engines, they know for a fact, so they are like, let's do not flex the CPU too much, let's keep 20% power reserve just for crunching the data. So you get that point. Like that's the inherent limitation. It's a fundamental pipeline limitation. Again, it made sense back in the day, now it's acting as a choke point. So consoles start to realize this very early on, simply because you have to understand it. Consoles are always inferior hardware compared to CPU, and even if they are not, they are compromised in some other ways. For example, they may have a CPU that's awesome, that's like latest and greatest, much better than any CPU you can buy, but it will be like, yeah, it's paired up with a much smaller RAM, or it may be paired with much weaker GPU, or maybe like, in desktop era you could have a like 2 GB RAM and 1 GB VRAM. This puppy will be like 4 GB shared. So that's the whole process. It's always inferior hardware. It always has been and it always will be. Otherwise, it will simply not be cost competitive. It will be. So that itself is bad. On top of that, CPU start in the early days were not developing very fast enough. However, they started to pick up steam in our early 2005s. Then it started to become like, in those sort of scenario, consoles still requires billions of dollars to invest. It still requires billions of dollars in tooling cost, manufacturing cost, R&D, and all that jazz. So you need to keep that puppy in market for around a minimum of 6 years. Otherwise, you're gonna lose money on that. So that creates an issue. How the heck you create an equipment that stays there for that long on an inferior hardware? Well, you do have one advantage of consoles. The greatest advantage all consoles have is basically their one thing, meaning their kernel is locked, their operating system is locked, their hardware is locked. Meaning, if you want to create a new pipeline, you know how to manage it. You do not have to, okay, how the heck it's gonna work in AMD system, how the heck it's gonna work with NVIDIA system, how the heck it's gonna work with Intel system. You don't have to do it. It's like, dude, this is the hardware, make it work for it. Or you can even have a talk, like game developers who are like, generally Sony literally talks with them, and the game engine department will be like, what do you want? Like, what do you want? Like, game engine will like, what, if you can do this, like, I know you for a fact that you cannot give me like 38 gigabytes of VRAM, so how about you give them a direct path to SSD and you make the SSD as fast as possible. So do not give me SATA SSD, give me NVMe SSD. Sony is like, okay, I got you, fam. They went to PCI 4.0 basically SSDs. That way they can directly read write from the SSD itself. So that means even with a smaller VRAM, because they can directly read and write data directly into it, the VRAM performance acts like it's much larger. Like VRAM acts like it's 128 gigabyte compared to a very small gigabyte that it actually. Same goes with basically Xbox also. That's the whole point. Consoles had to do this because consoles are basically, especially after PS3 and Xbox 360, the next generation consoles were really not that good in terms of sales figure. They were not that good. They were like okay, but like really not that good. And not to mention, a lot of controversy also started to happen. It's like you are claiming these are full HD consoles and people notice that, dude, half of the Xbox games were running at 900p, and then they were stretched to full HD. That's not acceptable. And even PlayStation games were like, dude, you are still doing full HD 30 FPS, which you were doing in basically God of War kind of era of the PlayStation 3 also. So why the heck that was not changing? Simply because it did not have the enough horsepower. Fundamentally, it was inferior. So this technology gave them a fighting edge, meaning this is the main block diagram, because everything is in one chip. So you have IO block, IO complex as they say it. It directly reads the data, dumps it into shared memory. Shared memory basically figures it out. It's like, hey, CPU calls it, it gets from here. GPU calls it, it gets from here. They do no longer have to like go through the CPU for crunching and decrunching, meaning it makes this pipeline so efficient that it inherently acts as like a much larger cache. Rather than like, let's say 16 gigabyte, it will act like, hey, I have like almost 4 terabytes of cache. So if you put a really capable good SSD there, it actually benefits into having a smoother gaming experience. So that's why console kind of cracked this puppy 2 years ago. So what about the deployment of this technology into PC world? Well, it's a whole new pipeline, and the pipeline is so complex kind of thing that you cannot just change it like, software. No, it never works like that. It's a complete new tech. So what does that mean? That simply means hardware, software, operating system, everything has to change fundamentally for this. So GPU needs to have IO blocks and decompression block, meaning if you try to do it with old GPUs, it can try to do that, but it won't be very efficient, or many times it might struggle simply because it may be very good at loading it, but still may need to send the file to CPU for decompression. So thankfully, basically RTX latest from AMD and latest from RTX, I'm saying RTX, both of them have that ability, because they kind of figured it out. It's like, consoles are doing that, CPU is gonna get it sooner or later. So both of them have implemented those IO blocks and decompression blocks, so they can directly read data from SSD and do everything they need to do directly. They do not have to go talk to the CPU. So CPU is completely free. And operating system needs to change. That's why like Windows will only support this from Windows 10 and Windows 11. Do not expect Windows 7. And not to mention, flat out they are saying Windows 11 will be the better choice for that, because they have worked with the core operating system. Subsystems of the storage have been refined for this. So OS, kernels, all of those things have to be facilitated in such a way. So Windows 10 and 11 only, and SSDs may not be good enough for this. While it does, compared to 200 Mbps speed and hippity hop, it still would be faster to use a 600 Mbps SATA. But from all testing, you have to use something that is a bit more powerful, basically NVMe. And NVMe is the PCI Express protocol, so you will not have another protocol overhead. So NVMe 3.0 at least. Now game engine have to have the toolkit for that. You cannot just like, okay, I'm gonna develop the game as I used to and it's gonna work. No, it's not. It needs new game engines basically that have this functionality built into it. And the final nail in the coffin would be the game developers have to utilize that. Now that's not going to happen in day one. That's why you will notice that RTX hardware came into the market very early on, RTX 2000 series, but nobody was using it. Why? Because it takes time. And think of this way, I worked in a game that let's say PlayStation 4 Spider-Man. It took 2 years from me working on it, then it reaching the market, and it was like work behind the scene of almost 3 to 4 years. So always any game that is going to be released now, it was being worked on like as early as 4 years ago. So that simply means they will never take a risk at the end of the development where it's like, we're gonna change it. Now I was in a game studio which did try to do that, and it went bankrupt because they were keep changing game engine at the other end. It never works. So yeah, you have to wait. You have to wait for game developers to like, okay, Unreal people, they got your back. You still have to design the game from scratch up, basically from ground up till the final production. Then only you can utilize it properly. And it will take, from my estimates of game industry, it will take around 2024 when you can actually see games. Now again, be very mindful, many games will start to claim that they have direct storage, but they will not truly utilize it. It will like, it's there, but it's like, you really do not feel wow kind of difference, because again, they have to design a game in such a way that it's also backwards compatible. So that's kind of a hassle. But once 2024 around and this sort of new hardware becomes normal hardware, more and more people will slowly start to realize that developing games for direct storage in mind, direct storage API in mind, is far better, far more beneficial. So deployment will take some time. Now I'm talking about this, like this is a kind of like a very niche technology. Why I'm talking about? Because this is a paradigm shift, and any of you have played game, you would have noticed the game no longer looks like wow. The last wow event that I noticed in gaming industry was Battlefield 3. But when Battlefield 3 trailer first time came out in E3, people were like, whoa. that was like a big wow moment. But here's the deal, after that nothing more. Now be mindful, game has looked much better compared to that time, but there was no leapfrogging. It was like, you know, bit more refined, bit more polished, bit more this, bit more that. Like we worked in Forza games, it's like, okay, now the tracks, you know, the tracks have still high quality textures, but now they have dirt layer on them. It's like, okay, a little bit more, you know, all these things were happening, but they were not like wow. Now this is that wow effect. So that simply means after years of stagnation, there is a lot of potential, and environment artist is gonna love this, because that's the whole thing. Environment is the limiting factor, meaning you will always notice the main character, they're like damn good textures, damn good everything, unless somebody somehow figured out how to heck they messed up Halo, where they are seeing you know, collecting the fallen Spartan's helmet. It's LOD. Why the heck is not, like, how? But again, it does happen. Again, I've been on the receiving end of that art kind of situation, so I know it could happen. But I was like surprised. It's like, this is a main game. You're noticing in a cutscene that how the heck nobody noticed that it's loading the LOD asset rather than the main asset. Happens, but you get the point. Like developer teams, they're gonna love this once they actually start to utilize the horsepower of these things. And be mindful, these are also not gonna stay static. PCI 5.0 is already starting to come out, so by the time they build the game, they will test the game on, like, let's say 2 Gbps hardware, and by the time it's finally deployed, it may be running on a hardware that is 3 Gbps. It will be even better. So new large scale open world system can be done, and that's just one outcome. Be very mindful, it at the end of the day is just a toolkit. How somebody utilizes, that's up to them. They may build a amazingly idiotically large scale open world system, or they may build something completely unique, completely unknown of. It's like, hey, this was the tool, we thought we can do this. It happens. It has happened many times in gaming industry, and that's why, like, you know, many of the horror games, like, why the heck they're so eerie, so weird? Oh, because the technical limitation of draw distance. So you get that point. Like, give engineers some limitations, some tools, they can make some amazing thing out of it. So I do expect some paradigm shift, meaning by that 2025, you can notice the differences. Like, dude, this is a direct storage game, this is not a direct storage game. Like, that would be like night and day difference. So I do expect some good things to come out of it. And again, it will take time. Do not expect it to happen on day one. It will take some time. So this was my presentation on basically DirectStorage API for Windows. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.